Hi. In this video, let's see the harmonic property. A function is said to be harmonic if it satisfies the Laplace's equation, that is del square phi is equal to 0. So in Cartesian form, if phi is in terms of x and y, we can say that phi is harmonic if del square phi by del x square plus del square phi by del y square is equal to 0. The same thing in polar, we write this as del square phi by del r square plus 1 by r into del phi by del r plus 1 by r square into del square phi by del theta square is equal to 0. So we have to memorize these two statements. And here the real and imaginary parts of an analytic function are harmonic. What are those real and imaginary part? U is a real part and V is the imaginary part. So we are saying that U and V are harmonic. Okay. Of course, we can prove this from CR equation. It's very easy, the proof. So they won't ask this in the exam, but still. We have ux is equal to vy, CR equation, right? Del u by del x is equal to del v by del y. So if I partially differentiate with respect to x again, what I will get? Del square u by del x square is equal to del square v by del x del y. We have two CR equations, right? What is the second CR equation? Del v by del x is equal to minus del u by del y. So we are partially differentiating this with respect to y. So we'll get del square v by del x del y is equal to minus del square u by del y square. Okay. So now we have equation 1 and 2 and we are going to equate these two. So what we will get? Del square u by del x square is equal to minus del square u by del y square. Okay. If I bring this to the other side, del square u by del x square plus del square u by del y square is equal to 0. So actually what we have to prove in Cartesian form, del square phi by del x square we have written in the formula, right? So in the place of phi I have u, then it means u is harmonic. Similarly, we can prove v is harmonic. Take this side, find del square v by del x square and del square v by del x square and you will get the desired result. Now let's see problems based on that. So they will ask you to find the harmonic conjugate. It means if they have given u, you have to find v. So of course we can find v by using Milne-Thomson method also. But in the question they will ask, prove that u is harmonic and find its harmonic conjugate. So you have to prove by this method. If they didn't mention anything, then what you can do? From u, you will construct the analytic function f of z, and again wherever z is there in that f of z, we will replace it by x plus iy if it's Cartesian. Then you can segregate u and v. U is your question and v is what we are going to find. But here we are going to prove that it is harmonic. See the question, prove that u is harmonic and find its harmonic conjugate. So also determine the corresponding analytic function. So we have to find v as well as we have to find f of z. Okay. So this is an VTU question. Now I have to prove u is harmonic. So what I have to prove? Del square u by del x square plus del square u by del y square is equal to 0. Don't write v here. Both are u. If u is harmonic, I will write u in the numerator. So now we have u. Please better to write u once again and decide whether there is a multiplication when you are differentiating. See, we have e power x as first term and second term again contains x cos y minus y sin y. So u v in differentiation we are going to follow. Differentiation of u v is keep u as it is, differentiate v, plus keep v as it is, differentiate u. This is the procedure, correct? So same thing we are going to follow. So first keep e power x as it is and then x cos y. We are going to partially differentiate with respect to x. It means I will differentiate only x. X differentiation is 1. Cos y is just a constant in multiplication. I have written that. And this y sin y completely it's a constant. So 0. Plus write this term as it is. X cos y minus y sin y into e power x. Differentiation is e power x. So I have underlined this. This is u and this is v. It's like first term and second term. Write first term as it is, differentiate second term, plus write second term as it is and differentiate first term. So now you've got ux. Now because we want del square u by del x square, so again you're going to partially differentiate ux with respect to x. Okay, so in this case also y is a constant, and we can decide where uv is coming. This is only one x term, there is no x term in multiplication, simple, easy. But here if you see, this term contains x and multiplication again, so again this is going to be u and v, two terms are there in multiplication. Okay, so keep e power x, cos y as it is, and e power x differentiation is e power x. Done, partially with respect to x, plus keep e power x as it is. This we are going to differentiate with respect to x, same what we did in the first step. So cos y is just a constant, x differentiation is 1, y cos y completely constant, so plus 0. So we have written only cos y, plus whatever which is there inside the bracket I have written, e power x differentiation is e power x. So twice we partially differentiated with respect to x. Now it's just a simplification. Take e power x common, cos y plus cos y, it will become 2 cos y, then plus x cos y minus y sin y. So you got uxx. So this term you've got. Now I have to find uyy. So partially differentiate u with respect to y. So again I have written u inside the box. So it will be easy for you to decide where multiplication is coming in y. So at that time you have to apply uv. See, e power x is just a constant because this time we are going to differentiate with respect to y. Again x into cos y, only one term is there, but here if you see, y into sin y, two y terms are there. So here you are going to apply differentiation in uv method. So please be careful. So u is given, partially differentiating with respect to y. Okay, so keep this e power x as it is. Okay, then we have x into cos y, keep x as it is, cos y differentiation is minus sin y, minus we have two terms, so please be careful, open the bracket, write y as it is, sin y differentiation is cos y, plus write sin y as it is, y differentiation is 1. Okay, so it's better to rewrite u next to it so that it's easy for you to write down. So first term e power x as it is, here cos y differentiation is minus sin y, and here these two terms keep y as it is, sin y differentiation is cos y, plus keep sin y as it is, y differentiation is 1. Is that clear? Now all the terms are having a minus, right? So we'll take that negative outside to avoid confusion. So if I take minus outside, so I'll get plus x sin y plus y cos y plus sin y. It's easy for us to again partially differentiate with respect to y. And check this, where you are having two y terms, only this other differentiation is easy. Okay, so e power x, again I am writing as it is because we are partially differentiating with respect to y, x is a constant. I think by this time you will be used to do partial differentiation. And keep x as it is, sin y differentiation is cos y, plus now it is uv multiplication, right? Keep y as it is, cos y differentiation is minus sin y, plus cos y and y differentiation is 1. Finally the last term, sin y differentiation is cos y. So I have underlined this, we have uv, so I have written this. So you got uyy also. What I have to do, if I add these two, I should get 0. And you can see this term, cos y plus cos y, it will become 2 cos y, correct? 2 cos y plus x cos y minus y sin y, correct? So what is uxx? Here it is, same, e power x into 2 cos y plus x sin y minus y sin y. Everything is there with opposite sign. So if I add these two, I'll get 0 for sure, which means u is harmonic. Okay, so we have proved that it is harmonic. Now we have to find the harmonic conjugate v. Okay, so to find v, we can find v in both the ways. These are the two CR equations, ux is equal to vy and uy is equal to minus vx. From this I am going to find v, and from this also I am going to find v, and I will compare. Because if you take the first equation, ux is equal to vy, correct? So already I have ux already we got it. So vy is equal to, that is del v by del y is equal to e power x into cos y plus x cos y minus sin y. You can take e power x from the first half, no need to find it again, because we proved that it is harmonic, which means your u power x answer is correct. So just for fun, don't write hence proved in the beginning if you don't get the answer. Find out where you have done the mistake. Okay, so you have replaced ux by this term. Now if I integrate with respect to y, I will get v. But we are going to integrate partially, because del v by del y is there. Since we are integrating it partially, we will add a function of x. So we are going to integrate with respect to y, so we are going to add a function of x. Okay, so better you can mention we are going to add a function of x. Now see this carefully. V is equal to e power x into first term integral of cos y plus x into, we are just throwing out the x term, integrate with respect to y. So cos y term as it is, dy should be there in all integration. If x is there dx, y is there dy, minus integral y sin y dy. Now if you see integration by parts, if it's in multiplication, integration by parts. What is the formula for integration by parts? Integral u dv is equal to uv minus integral v du. So integral of cos y is sin y. Differentiation of cos is minus sign. Please be careful with the differentiation and integration, because first half we are differentiating, second half we are integrating. You have to be very much thorough with the formulas. So integration of cos y is sin y plus x into integral of cos y again sin y, easy, minus, now we are going to apply the formula. Integral u dv is uv minus integral v du. So what is u? The term that's going to vanish after differentiation is u. So y will vanish. So u is y. Y I have written. And this is dv. Correct? So u I have written. V is integral of dv. So sin y integration is minus cos y. Minus integral v du. V is minus cos y and dy. So for those who are little confused with the basics, I have written what is u is y, therefore du is dy, and dv is sin y dy. So integral of dv will give you v, integral of sin is minus cos. That is what I have written. So u v minus integral v du. Okay, and plus f of x. Remember, this is very important because I am partially integrating with respect to y, so I am adding a function of x. Because when I differentiate function of x, I am keeping that as constant, right? So I have to compensate that. That is why I am adding a function of x. Okay, because remember, if only pure x terms are there, and if I partially differentiate with respect to y, those x terms will become 0, right? So when I am integrating, I have to compensate for that, so I have written f of x. So integrating with respect to y means add a function of x. Integrating with respect to x means add a function of y, as simple as that. And now we are just going to simplify. E power x we have taken common, sin y we have written as it is, x sin y as it is. This minus and minus will become plus. This minus and this minus is plus, but there is already one more minus. I made a small mistake. I wrote plus here first and then I realized one more minus is there. So please be careful with the silly mistakes. And finally, integral of cos is sin only. So this minus and minus plus, one more minus is there, that I have written, plus f of x. So you got v. And of course plus sin y and minus sin y we have cancelled. So v is e power x into x sin y plus y cos y plus f of x. We got v. So we'll be thinking that the problem is over. No. We have to find what is f of x. We don't know what it is. So what we are going to do is, we are having two CR equations, right? So we used only the first CR equation and we got del v by del y. From that we integrate with respect to y. Similarly, using the second CR equation, uy is equal to minus vx. Therefore, vx is equal to minus uy. Vx is nothing but del v by del x. And then remember, already we have done uy. In uy we are having a negative sign. Let me show you why. Yes, see here, this already we have done uy. This negative sign is there, right? So this negative, and in the equation vx is equal to minus uy, that negative will become plus. Yeah. So that is what I have written plus. Such a big question, but don't lose hope. We are almost done. So integrating partially with respect to x, because it is del v by del x. So we are partially differentiating with respect to x to find v. So if I differentiate with respect to x, what I should do? I should add a function of y as a constant at the end. So don't write f of y because the functions won't be similar. So write some other name, your name, initial, whatever it is. There you have written f of x. So here g, some g of y, you write it. And now we are going to integrate partially with respect to x. So y terms are constant, so you can throw it out. Okay. So x into e power x is there inside. Sin y I have thrown outside. You have to, because e power x is common for all, and this is not a constant, so we have to take inside. What is the second term? E power x into y cos y. Y cos y is just a constant, throw it outside. E power x, good. And then third term, sin y into e power x. Sin y as it is, integral of e power x. So if you see this, this is easy, this is easy. Again, integration by parts. X is u and dv is e power x. This is easy because e power x integration is also e power x, right? So write sin y as it is, u v, u is x, dv is e power x, v is also e power x. Okay, so if you want, I can write dv is equal to e power x, v is integral of e power x, that's equal to e power x. I have to write e power x dx. Yes. Okay, so uv, x into e power x minus integral v is e power x, du is dx. Done. Then next term, y cos y, integral of e power x is e power x, plus sin y into integral of e power x is e power x plus g of y. Don't lose hope, almost we are done, because your answers will be almost same, exactly same. Okay, so you can solve this very fast. And just going to integrate e power x. E power x integration is e power x only, so after that only simplification. At last we've got v x e power x, just we have multiplied all the terms, x e power x sin y, e power x y cos y minus sin y e power x. Already one more sin y e power x is there, so it get cancelled, plus g of y. Don't leave this function, this is very important. Already we have calculated v, right, by partially integrating with respect to y. This is this answer. This is already we have got this, and this now we got. Compare this, both are same. There probably we might have taken e power x outside, just multiply and write it like this. So in the x e power x, x e power x, both the terms are there. Good. Then what is the next term? E power x y cos y. Good. Same term we have got. So it means if you have done a mistake, the terms will be different. Okay. Now, I have to find g of y here. Is there any term that contains only y here? There is no such term. So g of y is 0. Happy. Again I am searching. Is there any term in this previous answer that contains only x? Combination of x and y, combination of x and y, there is no only x, so I have written 0. For example, if I get plus x square into g of y, so I will write f of x is equal to x square. Okay, so similarly here plus y power 3, one more y term is there, then I will write g of y, then I will add these terms to the final answer. So we have decided that f of x is 0, g of y is 0, and this is your final answer, x e power x sin y plus e power x y cos y. So this is harmonic conjugate. And they ask us to construct the analytic function. This is very easy. U plus iv, you know what is v, just now we got u plus iv, put x as z, y as 0. Milne Thompson anyhow you have learnt. So if you replace this, z into e power z, cos 0 is 1, z e power z, this will become 0, this will become 0, and begin again cos 0 is 1, but still into y is there. So this is your analytic function. So I'll repeat the procedure. Since in the question they asked us to prove that it is harmonic, we have proved del square u by del x square plus del square u by del y square 0. And of course you have ux and uy, we will use this in the further formula. Because ux, I'll replace it by vy. Okay. After replacing by vy, I'll integrate with respect to y and add a function of x. Similarly, uy, I will replace it by, that is v minus uy is vx. So vx is equal to minus uy. So if I replace this by vx, then I have to integrate with respect to x and add a function of y. Finally, we are comparing both the answers. That's it. Such an easy problem. Now, this is a question similar to that in polar form. Of course, this is very easy. Show that u is equal to r plus 1 by r cos theta is harmonic. Find its harmonic conjugate and also the corresponding analytic function. This is going to be very easy. This is u, r plus 1 by r cos theta given in the question. To prove it is harmonic, what I have to prove? U r r plus 1 by r into u r plus 1 by r square into u theta theta is equal to 0. Okay. In the beginning, actually I proved only for Cartesian. We can prove it for polar also. Same from CR equations. Okay, now coming back to our problem. Partially differentiate with respect to r, which is a constant, theta is a constant, write cos theta as it is, r differentiation is 1, 1 by r differentiation is minus 1 by r square. Done, we are done with ur. Now again urr, again partially differentiating with respect to r, theta is a constant, write cos theta as it is, 1 differentiation is 0 and minus 1 by r square differentiation is 2 by r cube. This already I have taught you, r power minus 2, then if I differentiate it, minus 2 r power minus 3, this minus and outside minus will become plus 2 r power minus 3, if it goes to the denominator r power 3. Okay, you are done with urr. Now we will find u theta. Partially differentiating with respect to theta, r plus 1 by r I will write as it is, cos theta differentiation is minus sin theta. Done. Again u theta theta, write down this as it is, sin theta differentiation is cos theta. This minus is there already. So now we are going to substitute urr. Okay, we have written this, plus 1 by r into ur, plus 1 by r into ur, we have written this. Okay, minus plus 1 by r square into u theta theta. So u theta theta is having minus, that minus I have written. So 1 by r square into u theta theta. So we've got this, and of course if this term and this term will get cancelled, and obviously u is harmonic. And you will be wondering how it got cancelled. Actually you have to simplify this. 2 by r cube cos theta plus 1 by r minus 1 by r square into r, minus 1 by r cube cos theta, again minus 1 by r, again we will get here, then minus 1 by r square into r cos theta. So if you multiply and simplify, you will get the desired result. So once u is harmonic, what we will do? We are going to replace v theta by using CR equation. What is v theta? R into ur. So we know what is ur, this one, oh my god, it's not visible, 1 minus 1 by r square. So since we multiply r, so I have multiplied r in the numerator, r minus r by r square cos theta, and this r will be there as it is, this one more r will get cancelled, so r minus 1 by r cos theta we will get. And this is very easy, integrate with respect to theta, r is a constant, throw it outside. So integral of cos theta is sin theta. And when we integrate with respect to theta, we will add a function of r. This is very, very important. Remember, finally we will compare both the answers. Okay, so we got v from this. Similarly, r Vr is minus u theta. Therefore, Vr is minus 1 by r u theta. So what is u theta? U theta also you have already got. Let me show you u theta. Yeah, here it is. Minus r plus 1 by r sin theta. So this minus and this minus will become plus. 1 by r is there already outside. R plus 1 by r sin theta. Now multiply this inside. 1 by r into r will become 1 plus 1 by r square sin theta. So now we got VR, we are going to integrate with respect to R, therefore add a function of theta here. So with respect to R means sine theta is just a constant, so we have thrown it outside. So 1 plus 1 by R square dr we are going to integrate. One integration you have to write R, and 1 by R square, if I integrate, it is nothing but R power minus 2 if it comes to the numerator, R power minus 2 plus 1 by minus 2 plus 1. So we will get minus 1 by R. You can simplify on your own. This is very easy. Okay. So R minus 1 by R plus G of theta. Now we've got V here and V here. So is there any theta term, pure theta term? No, it is a combination of R and theta. There is no pure theta term over here. So it means G of theta is 0. In this answer, is there any pure R term over here? No R term, because R and theta combination. So I will search f of R here, and I will search this G of theta here. Very simple. Okay. So f of R is equal to 0 and G of theta is equal to 0. So happily we can conclude that V is R minus 1 by R sin theta. So here one advantage is, see here, both the answers will be same if you are doing it properly. So you can guess whether your answer is right or wrong. Okay. And we have to construct the analytic function too. So f of z is u plus iv. U I have written, plus I into v also I have written. And what we will do? Substitute r as z and theta as 0. So we will get z plus 1 by z as a solution. So similarly we can do v is harmonic. We have to solve one problem in Cartesian and one problem in polar. Hence we are done with harmonic conjugate. Thank you.